Hello everyone, this is the example 4 of analysis of statically determinate structures, and this example I will solve this problem. And it says the compound beam in figure is fixed at A. Determine the reactions at A, B and C. Assume that the connection at B is a pin and C is a roller. So all support conditions are defined in here. So first we have to recognize support conditions, and they say A is a fixed support. When we have fixed support, we usually mark three components, which are two force components and one moment components. So I wrote it here: AX, AY and MA. Those are the three components of point A, and that is a fixed support. And next I will show you support condition of C. So it is simply support, and when we have a simply supported condition, we mark vertical force component. So I marked Cy here as the vertical force component, and this 6000 Newton meter moment is in the original problem. They have given us that value, so that doesn't matter. And next we have point B. Point B is a pin connection. If we have a pin connection, we separate our beam from that point. So I separate into two parts of this whole beam as AB and BC, and at point B we mark two forces in both parts, and there is a AB and BC. Both beams have point B, so both points we mark two forces. So I mark two vertical and horizontal forces, BY and BX. Here also BX, BY. Values of these forces are same, but the direction is opposite. Here this vertical force BX is directed to the left direction and BX is directed to the right direction, but value is same, BX equals BX. And BY in AB part, BY is directed to the upward direction, but in BC, BY is directed to the downward direction, but value is same of these both BY. So those are the support reactions, and then there is 8000 Newton. It is the resultant force of this distributed load of AB part. So I can get the resultant force by multiplying 400 by 20. If I multiply 400 times 20, I can get 8000 Newton. And since this is a uniformly distributed load, it is acted middle of the AB. Length of AB is 20 meters, so this resultant force is acted length of 10 meters from A and length of 10 meters from B. So now I can determine support reactions. For that, first I consider BC part. So this part, I write equation for this BC part. So first I take moment about B, about this point, and it is clockwise direction. So I take moment about B clockwise direction. So if I consider B part and if I take moment about B part, this BX and BY forces are not in our equation, but we have to consider CY and this moment. So since I consider clockwise direction, I have to write 6000 plus 6000 because this moment is clockwise direction. Then CY, moment due to CY is counterclockwise direction, therefore I put minus sign. So CY we don't know, therefore I wrote CY here, and distance between CY and this point B is 15 meters. So therefore I wrote 15 meter here. So when I simplify this, I can get CY equals 400 Newton. Next, I consider horizontal forces. So here also I consider BC part. I take sum of all the horizontal forces. So there is only one horizontal force, therefore BX equals 0. Now I know BX and CY. Next I consider sum of all the vertical forces. Here also I consider BC part. If I consider vertical forces, there are two vertical forces BY and CY, and I consider upward direction, therefore I wrote plus CY minus BY because BY is downward direction. So if I substitute 400 for CY, because we found it before CY as 400, I can simplify this as BY equals 400 Newton. So now I know CY, BY and BX. Since I already found BX and BY, I can substitute those values for these BY and BX in part AB. Now I consider AB part and I take sum of all the vertical forces. So now I know value of BY. There are only three forces that I have to consider, which are AY force and 8000 Newton force and BY force. So here BY force is I already know. So I write the equation. I consider upward direction. Therefore I wrote plus AY. Then minus 8000 because 8000 is acted downward direction. Then plus BY because BY is acted upward direction. So I know value of BY. BY is 400 Newton. So I can simplify this equation and I can get AY equals 7600 Newton. Next, I consider all the horizontal forces of this AB part. So there are two horizontal forces, AX and BY. So I write the equation considering right hand direction plus AX because AX is the same direction which we consider, and minus BX. BX is the opposite direction. So BX is equals to 0. We found it before when we consider this BC part, and when I substitute value for BX, I can get AX equals 0. Next, I have to only find this MA moment. For that, considering AB part, I will take moment about point A to the counterclockwise direction. So I will write the equation. First I will write MA as plus MA because MA is the same direction which we consider counterclockwise direction, and minus 8000. 8000 is this resultant force. If we take the moment of this force, it is rotate like this. That means it's clockwise direction. So we consider counterclockwise direction, therefore I put minus sign here. 8000 is the force. Distance between 8000 force and point A is 10 meters. Therefore I wrote 10 here, and plus BY. Moment due to this BY force is counterclockwise direction. Therefore I put plus sign here, and BY, I wrote BY. It is the force, and distance between BY and this point A is 20 meters. So now I have to substitute the values which I know. This BY force is I already know, so I substitute 400 as BY, and 400 times 20 I can get 8000. 8000 times 10 is 80,000. So I can simplify this and get MA equals 72,000 Newton or 72 kilonewton.